In this last lecture on testing the difference between two populations, we consider hypothesis tests for proportions. Just as with the mean, the format for the three types of hypotheses are the same for the left, the right, and the two-tailed. We've already seen the formula for the standard error of the difference between two proportions. And we have a new formula for the pooled estimator of the proportion when the two proportions are equal. We will use the Z statistic in doing our hypothesis testing, and therefore our Z test value is shown here. For example, we will consider a change in proportion before and after using a 0.05 level of Z. We set the alternative hypothesis first because we are trying to prove that proportion 1 is greater than proportion 2. Therefore, alternative hypothesis is P1 minus P2 is greater than 0. The null hypothesis is the opposite of that. Calculating our test statistic, we first calculate the pooled estimator P bar as 0.45, and we calculate a standard error of 0.0514. Therefore, our test statistic, our z-test, is 1.56. Using the p-value approach, we find the p-value from the z distribution table for z of 1.56 to be 0.0594. Given that this is greater than our alpha of 0.05, we cannot reject the null hypothesis. Therefore, we cannot conclude that the proportion of households aware of the product changed or increased with the new campaign. Following the critical value approach, for a z of 0.05 for a one-tailed test, we get a critical z-value of 1.645. And we will reject if our z-test is greater than that. Our z-test was 1.56, which is not greater than our critical z. Therefore, we cannot reject the null hypothesis.